All right, let's continue with the next talk. Hey, sorry. Thank you. All right, the next speaker is, let's see if I can do this, a longtime geomatician, with a passion for data, statistics, open source, and decentralization. So we have Pavel Bautista. We'll talk about how monitoring Ethereum's beacon chain, a DEFCON alert system for safety and liveness. And this will be a 10-minute talk, so we won't do questions in the end. Take it away, Daniel. No, sorry, not Daniel. Pavel.
So, hi everyone. So, my name is Pavel Bautista. So, I'm here to share the work I did with the collaboration of Miguel Labs. So, yes, I started working 6 years ago as a geographer, and then last year I decided to do a data science and AI bootcamp. And at the end of last year, I had the opportunity to do internships with Miguel Labs, which I did, and I finished 2 months ago. And actually, we achieved to publish 2 blog posts on its research about this topic. Actually, here you have the QR code if you want to go deeper in the work we did. And then I'm here today to talk to you about our work. So why a DEFCON RE system for the beacon chain? So first of all, what is a DEFCON RE system? Well, DEFCON means Defense Readiness Condition. That is something used by the US military. That means that we have different kind of levels of alerts. Level 1 is the most severe, meaning the end of the war almost, and level 5 meaning everything is going just as expected. So a quick reminder: why do we need? Why we thought that it will be useful to have a DEFCON system for the beacon chain? So as a quick reminder, the beacon chain is composed by epochs. Each epoch has 32 slots, and each slot should have a block proposed. So to have a block proposed, we need, of course, a proposer and then validators making attestations. So we have 3 kind of attestations. We have source, target, and head attestations. And for source and target attestations, we need validators to reach agreement, to create consensus. We need 2/3 of validators agreeing. And for head attestations, we need more than 50% of validators agreeing. So actually, what we have here is the source correctness percentage. So here it's a figure, the orange or yellow line is the source correctness percentage. So the correctness percentage is the amount of validators that did the work on time and correctly. And the blue line is the 30-day average. And then you have the red dotted line, that means the 99 percentile, which means that actually since the beginning of the beacon chain until February 8th of this year, 99% of epoch had a correctness percentage above 95%, which is pretty good. And yeah, so the x-axis actually is the timeline, and the y-axis is the source correctness percentage. And actually, what we can see here, so here we analyze over 340,000 epochs. And what we have here, you can see the red arrows that show some dips. And actually, in the background, we have light colors with the hard forks. So what we can see here is that in the hard fork transitions, we had some dips in correctness percentage, which is something we kind of expect, because you have nodes that are not updated at this moment. Here, and with this black arrow, we have an important period where correctness percentage went below 66%, which means that the block finalization was not ensured. So a big problem that happened in May 2023. And then what we found is that we have some other moments. What we have concerning dips in correctness percentage. And actually, we don't know why this happened. And we don't even know if the community was knew that this was happening at the time. So that's why we decided to create a DEFCON alert system, so we can have different levels of alert and saying like, hey, be careful, correctness percentage is not going as well as expected. So how to detect these anomalies? Well, first we need to identify key performance metrics, and then we needed to define thresholds to each level. So how do we manage to do this? Well, the beacon chain, as you know, is a distributed system. For distributed system, we have two key notions that we can use that are safety and liveness. So safety meaning that nothing wrong should happen, and liveness meaning that something good will eventually happen. For safety, we decided to go with source and target attestations since these attestations are in charge of block finalization. And for liveness, we decided to go with head attestations and missed slots. So we analyzed over 340,000 epochs, and actually we tested different time frames, and we decided to go with a time frame of 112 epochs, which mean almost half a day. So for the safety results, actually here we have a table with 4 metrics. So the minimum source correctness, which is the minimum source correctness recorded within this period. We have the same for the target correctness. And then we have the source coefficient of variation on the target coefficient of variation. So the coefficient of variation analyzes the variability within one period. And just as a reminder, we have 99% of epochs performing well. So we can say that when we have a lot of variability, it's because we have a lot of dips in correctness percentage, which is not what we want. And here we have 4 levels. Level 1 is the worst thing, exactly what we do not want to happen. And level 4 means everything is going as expected. And inside the table, we have the thresholds we found. So here we have 2 figures on my left, so you're right. Yeah, we have the target. So for the 2 figures, we have dots. Each dot is a half-day time period, and the color of each dot is the safety DEFCON level. So for the figure on your right, in the x-axis, we have the source minimum correctness percentage, and in the y-axis, we have the target minimum correctness percentage. So we want all the half-day periods to be at the top right of the figures. And here we can see that actually the classification we did worked pretty well. And in the other figure, we have in the x-axis the source coefficient of variation, and in the y-axis the target coefficient of variation that we want to be as low as possible. And we can see that what we want is to have all values, all half-day periods at the bottom left side of the figure. About the liveness results, we found 3 metrics, so the minimum head correctness, the head coefficient of variation, and the average missed slots. Again, we have 4 levels, and what we found here is, well, again, each dot is a half-day period. Here, the size of each dot is the average mean slot, so the bigger, the worst. And in the x-axis, we had the head minimum correctness percentage, and in the y-axis, we had the head coefficient of variation. So here we can see that our classification worked pretty well to create different levels of alert. And just to finish, we can say that actually the time frame we decided to use was really useful because it allowed us to detect short-lived anomalies like what happened in May 2023, but also to detect prolonged instable periods. We can see that the DEFCON system is kind of useful to detect a concerning period of time, yeah, and that actually is a tool that can be used by the community to investigate and trying to go further in what happened at this moment. And we think that this work can be adapted in the future, supporting multiple time resolutions and work with real-time data. So thank you if you have questions.